All right, so first thing we're going to look at is kind of a combination of two sections, but it's not really more material than we normally do. There's just a little bit of stuff we never did in section 1.2, and a little bit of stuff we never did in section 1.3, and we're going to kind of wrap up those two sections today. So we're going to solve equations that have parentheses. Okay. So you might have something like that. So it's going to be what you just did. It's going to have distributive property, but it's also going to have equals a number on the other side. So this is going to require us to use distributive property, and we're going to go through again the steps to make sure you follow, and I think today the problems are going to have all the steps. Yep, it's going to have everything in it.
Guys, you don't have to look back. I think you guys, I know it says that in your notes, but the first step when we solve the equation, right? We had the first like, it was like the big idea, and we had like two things that fell under it. What was that big idea? What's the first thing we have to do? There's two ways you can do it.
Oh, it
starts with an S. Simplify, yeah. Simplifies one. Now, I'm going to simplify, right? Last week, the ones we did when we simplified, right? What was one thing we could do?
Let's start with the other one. We'll put them in the order you have to do.
I understand.
Yeah. So what did we just practice in the warm-up, and then we'll get back to what Mr. Roy just said. What property? Yep. Distributive property. You always have to do distributive first. If it's in the problem. Does every problem have to have distributive in it? No. The ones we did last week, none of them did. Distributive property.
And what does that mean, guys? What math operation do you have to use? X? Multiplication. What are you going to do? Can you explain it to me? Zane, what you have to do?
Like say if you have a number outside the parentheses, you can distribute to the numbers inside the parentheses.
Perfect. Yeah, it's the number. So Mr. Hager put a little like picture up there. It's the number outside times however many numbers there are inside. Now, again, someone remind me, how do I know what sign belongs with what number? Where am I going to find the sign that belongs to that number? Anybody remember? Which side? Sophia? The left. Right now, here's the trick question. What if there's no sign? What kind of number is it? There's no sign to the left of it.
Positive.
Positive. We always, if no sign to the left of it, we always assume it's positive. So whatever number, whatever sign is inside the parentheses here, if there's one in the middle, it's going to go with this number. All right, it's going to go with the number on the right, or the last number inside the parentheses. And there might be a negative one here too. All right, remember the sign to the left always goes with it. And we had a couple like that in the warm-up. So just keep that in mind when we do these. If you want a circle number on the inside of the sign, so you don't forget it, you can do that too.
Now, Mr. Roy was reminding you guys about something we had to do under Simplify that came up last week. And you guys did it. You did it in this problem right here.
So the one,
did you do it in this problem? No, they didn't.
so the ones we had last week, right? We simplified, but we can only do this one part of simplifying. 3 words.
Combine the like terms.
Combine like terms. Now, as Mr. Hager's writing that, does anybody remember what's the catch? What's the only way you can combine like terms? Where do they have to be? Same Joe. They have to be on the same side of the equal sign. You can't take one and combine with one on the other side. Because if you do that, you're going to have to use the opposite operation if you want to do that. That's when we're moving variables. We're not at that point. All right? So they can only be on the same side. And you could have like terms on both sides. It can't happen. All right? How do we know they're like terms? Fred, how do we know they're like terms? If I said to you, Fred, I said 3x. Give me a like term. 6x, right? Because it has the x attached. Z, if I said 3, give me a like term. 4, right? That's just a number. So it's going to either have the same variable, or it's just going to be a plain old number. Either way works. And we're not going to get into anything where you have like 2 variables, like 2xy and like negative 5xy. We're only going to keep it to 1 variable.
All right, so now Mr. Roy was starting to talk about like moving things from side to side. That's the next 2 operations. And the next 2 after that. But what are the first 2 operations to start moving stuff side to side?
Add and subtract.
Yep, I'm going to add and subtract.
remember when we're moving stuff, right? What do we have to do
Do it to both
to be able to
sides.
move it?
Do it to both sides.
Do it to both sides. But what, Joe, if it was like a +5, to move it, what do you have to do?
Subtract.
-5, right? Remember, you have to do the opposite, you have to use the opposite operation. And you're not gonna, don't combine it with like a -2x on the other side. Only match numbers with numbers, variables with variables when you move them. So it's kind of like a little, kind of like combining like terms, but you're using the opposite operation. But you can't combine a number to a variable or a variable to a number when we're at that point.
All right, so now after we've simplified, we've added and subtracted, you might have something like, I don't know, you might have something like that. So, and there's that one other case you could have too. What would be our last two operations? Connor?
Multiply and divide.
Yep. Multiplication and division.
So when Mr. Hager was writing this, guys, he put the 3 equals 6x. He said you could have that, but you could have something else. Does someone want to give Mr. Hager an example of what that something else could be? An example of what you might have to do? He kind of has already given you a hint right there. So to do this, right, to solve this, what do I have to do to simplify that? What do I have to do? What operation? Is
Divide
that-
on each side.
Huh? Divide on each side, right? Good. So that's when we have to do division. What would an example look like where you have to divide? What would an example look like for the last step where I had to divide? And Mr. Hager gave you guys a little, oh, he have the equal sign. So that's it. We're using division there. Give me one where we have to use subtraction.
Multiplication.
Multiplication, I'm sorry.
Equals x divided by 2.
Yeah, that works. So you just know when you're going to use multiplication, you're going to have a fraction. Most of them, the majority of the ones we do, guys, for these are going to have whole numbers. You're going to use, and most of the stuff we do during the year when you have to solve an equation, it's going to be, you're going to have to divide. That's every once in a while you may have to multiply, you may have a fraction there.
All right, so in the warm-up, I know we did something like this. What property is involved here under the simplify step? Yeah?
Distributive.
Distributive, and can somebody else tell me what you are distributing? Because it's not really written there, it's kind of hidden. Yep?
-1.
Yeah. Whenever you don't see a number,
Yep.
you can always put in a -1, and that is what you're distributing.
Again, obviously the numbers and things like that are different in this problem, but how is it different from what we did in the warm-up? Anybody know how it's different from what we did in the warm-up?
Yeah, there's a 12 equals.
There's an equal sign, right? And what were the directions in the warm-up? Anybody remember? What do we have to do in the warm-up?
Use the distributive property to simplify the equation.
So what do we have to do in that? I know we have to use distributive, but what do the directions say?
It's the key word
What's the
there.
key word there?
Simplify.
Simplify, right? So simplify those. So what does that,
No, this one we're trying to.
what does that mean? What does that mean though, Mallory? We have to simplify. What does that mean?
Like make it the lowest.
Yeah, go as far as you can go. So what might not happen? Mallory, what might not happen when you simplify?
It might not come out.
Yeah, you might not get a nice A equals 2, right? You might have like 4A plus 5. That's simplified as far as you go. So we have to simplify. Now, what are the directions for Connor, what are the directions for this? What are we doing here?
Subtraction.
No, what do the directions say?
Solve.
Solve, right? So solve means, what am I going to get? Paige, what does it mean if I want to solve?
Get x equals.
Yeah, I'm going to get a variable equaling something. So this, I'm going to know the difference. We simplified the warm-up. That means go as far as you can. You might not get a nice one-number answer. Then we're solving. When we solve, yes, we're going to get a variable equals a number.
All right, so who can tell me right-hand side, well, we already said the property. Let's do it out. Do that out. Yep, Joe?
Would be -4x plus 8.
Good. So he did -1 times 4x. That's -4x. -1 times -8, +8. Other than that, everything here is just like what you guys did last week. Let's check for the next step. What's after simplify? Well, still in the simplify step, even if we don't need to do it here.
Addition and subtraction.
Still in the simplify step. We always want to check for
We
it.
don't have it in this problem, but it is a step.
Like,
Combine like terms. So as Mr. Roy just said, we don't have that. Now, the next step. Sophia just said addition and subtraction. Is there any adding or subtracting here? Gemini?
Positive 8, you have to subtract it to both sides.
Good, I like that. Subtract 8 from both sides. 12 minus 8 gives me 4 equals negative 4x. And now, what's my last step? Yes? Divide both sides by what? Careful, you got to divide. You not only want to cancel the 4, but you want to cancel. No, not the x. You want to leave the x. The negative. So we're going to divide by negative 4. Okay, so what do I get for x? Yep, Mallory? Negative 1. Okay. Do I have to do anything else in this problem?
No, because it just
It just said solve. Okay, it did not say to check. So solve means to do what we just did. Okay. What would happen if on the test all you showed me was that?
you wouldn't get any credit.
Yeah, you're going to get half credit because you didn't show any of the steps. Okay? And I think we're starting to get into problems where it's going to be kind of hard to just guess the answer anyway. Okay? Okay, any questions on example 1? All right, example 2. What's a little bit harder about this one than the last one? Yeah, no?
There's 2 terms on the other side of the equal sign.
Okay, yeah, there's 2 terms, and one of the terms has a variable in it. So now, once we do our first step, we have to make a few more decisions. All right, so first step, how about Xander? Can you tell Xander with a Z? What's my first step here?
You need to distribute.
And what am I going to distribute?
You need 3 to W and 4.
And the 4, good. Ginny, can you tell me what I get when I distribute? Oh, yeah. Yeah, I just, 3W. Anything else? Plus, I like that. She copied down the plus sign.
Plus 6, or 7.
Now, careful. What are you doing with the 3 and the 4? What operation?
Multiplication.
Multiplication. So, 12. Good. And on the other side, I just copied it down because I didn't do anything yet. Now, we have a decision to make. We either can keep the W's on the left, or we can put them all on the right. Anybody have a thought which way would be better here, Nathan? I would put them on the right. Why do you want to do that?
I was looking towards the 3W is smaller than the 4W.
Yeah, it's going to be perfect, because then if you move it, he said the 3W is smaller, it's going to keep W positive. And I should have asked you, how do you move it to the other side?
Yeah, I guess subtract.
Yeah, you subtract it. So, Paige, can you tell me, what am I left with now for a new equation?
12 equals 1W minus 5.
Yep. Is it okay to just write W, or do I have to keep the 1? I don't have to. I could put the 1. That's fine. Or you can just put W. And what's nice about getting a 1 in front of W is now you only have 1 step left. Okay? There's no number in front of W that you're going to have to deal with later. So what's my last step, Sophia?
Add 5 to negative 5 and add 5 to 4.
Add 5 on the right. Add 5 on the left. And can you tell me, Sophia, what you get for W?
17.
17. Perfect. Okay, it's a little bit more complicated because now you had a choice to keep the W's on the left or put them on the right. And I think you guys did it probably the best way. Anything else I have to do in this problem? How do I know?
Because it doesn't say check.
It doesn't say check, it just said solve, and we solved it. Okay, any questions on that? All right. I'm just going to ask you guys a couple questions and then give you a chance to try a little bit on your own. What is being distributed here? Gemini? Perfect. The -5 is being distributed. Should I distribute it to the 17 as well? No, that's that equal sign. That's where everything stops. We don't go beyond that equal sign. So take a couple minutes. Okay, see if you can solve that one on your own. Okay, and we'll walk around and help you out. All right, guys. So we kind of went through the first step was to distribute. We know it's a -5. So what happens to the 12? Nothing. You're just going to bring the 12 down. Now, what's -5 times 3r? Yeah? -15r. Not quite done distributive yet. One more thing. What's -5 times 2? Paige?
-10.
-10. What happens to the 17?
Nothing.
It stays the same. Now, as Mr. Roy said, you've got still something else under simplify. We did distributive property, but what else do you have to do now? Just on the left. Yeah? Combine like terms. What can you combine that 12 with? Yeah. You can combine it with a -10. Can someone else tell me what's 12 combined with -10? Or what's 12 minus 10? 2. What about the -15r?
You combine the minus minus 15R.
Just keep it. Nothing changes. 17? What do I do with that? Just bring it down. Nothing changes.
And then you add 17.
Now what do we do?
Subtract 2 from both sides.
Yeah, we've got the thing with the r is on the left. So we're going to put things without r on the right. So we get -15r equals, what's 17 minus 2? 15.
This is satisfying.
And now we're down to the last step.
Just,
What operation am I going to use in the last step? Just tell me the operation. Xander? Yep, we're going to divide. And we're going to divide by? So if we divide by 15, that's all that would cancel. R would not be by itself if we divide by 15. -15. Right? So, what do we get for R? Gemini? -1.
Oh, yeah. I didn't wait for this one.
And yeah, there are different ways to do it. You could have brought your R's to the right instead of on the left. But as long as you got the same answer and you showed your steps, you're good.
Are we doing all of these?
I think we have 3 more examples. One's a word problem, and then 2 more. All right. So Mr. Roy is going to take you through a more advanced problem.
All right, so guys, all the ones we've done so far have only had one set of parentheses. All right, these next 2 that we do will have 2 steps. 2 sets, I should say. Let's take a look. Oh, baby. All right, so what's one thing that I'm going to distribute in this problem? Give you guys a chance to write it down before we get going. Mallory?
The 3.
The 3, okay. 3 times what?
7.
What kind of a 7? Yep, 3 times a positive 7, and 3 times what? Positive 2y. So that's one thing that I'll distribute. I'm going to circle the positive 2y because as I'm walking around, I see some people making mistakes with their signs. So that's why I did that. So that's one thing that I'll distribute. All right. Anybody else see something else that I need to distribute? Paige?
You put a 1 in front of the positive.
Put a 1 in front of the negative, okay. Good.
And you distribute 1 and 4.
Careful, what am I going to distribute again?
Negative 1.
Perfect.
And 4.
I'm going to circle it too. I'm going to circle the sign with it so I know that's negative. So negative 1 times what?
4.
Okay.
And negative 1 times negative 2y.
Perfect. I'm going to circle the negative 2y so I know that it's negative. Now, before I even, what about that 6y? Is there anything I can do with that? Sophia, there's nothing. So what do I do?
So you bring it down.
Just bring it down. I'm going to draw a little arrow so we know. 6y. Okay. Now, before I even distribute, before I even write the numbers in, what's the sign of my first number when I do my distributive property? What's the sign of my first number going to be? The sign of my first number. Negative. Good, Joe. All I'm going to do is put a negative. Joe, how do we know it's a negative?
Because negative 1 times 4 is...
Yeah, it's a negative times a positive. There's no sign there, so we know that it's positive. All right? So negative for that. What number, Joe?
4.
4, right? Negative 4. Perfect. That handles that. So I did that. That's done. How about the other one I'm going to do, like Paige told me, is negative 1 times a negative 2. Fred, what's my sign going to be? A negative times a negative. Positive. Do you know what number? Negative 1 times negative 2? Positive 2. What else do I have to put there, Fred? The y, the variable. Perfect. So that handles that set of parentheses. That's done. All right. On the other side, somebody tell me, Sophia's going to tell me my first number.
3 times 1, 7.
3 times 1 or 7?
3 to 7.
All right, what do you
I was
get?
about to say y.
What do you get when you do that?
What?
What do you get when you do that?
21?
21. So, not negative 21?
No.
No, right? Positive times a positive is a positive. Don't do more than you need to do. Right? Don't change it around. Don't change the rules of math. Positive times a positive is still a positive. All right? Z, what's the other thing I have to multiply? Positive 2y and what number? 3, because it's on the outside. What do I get when I do that? Tell me the sign too, please. Positive 3 times a positive 2y.
You get a positive 9y.
Positive what?
9y.
I would agree if this was a 3, yes, it would be positive 9y. But it's not a 3, it's a 2.
Positive 6y.
Better. Positive 6y. So my distributive property is done. All right. So I distributed. What's the next thing I have to check and see if I can do? Joe?
Combine like terms.
Combine like terms. Joe, explain to me combine like terms. What does that mean?
You compare the two.
Not to throw your paper at me, though. Jeez. Sorry I made you explain it. No, it's such a big,
You
a sore spot
compare
for
the
you.
same variables.
Same, could it the same value?
Same thing.
Could it just be numbers? Okay. Where do they have to be?
On the same side of the.
All right. Do we have any here? Tell me the sign too, please.
Positive 6y plus, positive 6y and positive 2y.
Positive 6y, positive 2y. Same sign. All right? They're the same sign. So, Connor, positive 6y, positive 2y. What do I get?
Negative. Positive.
Positive, right? When we're dealing with positive, now at this point we're adding. We're not multiplying, we're not dividing anymore. We're adding now. When they have the same sign, what's the rule? When we're combining them. When they have the same sign, what's the rule? Gemini?
Add the numbers.
Keep the sign, add the numbers. They're both positive. My answer is going to be positive. What number, Connor? What number and what letter?
8y.
8y. Very good. What I'm going to do is, I'm just going to cross these out because I used them. Connor, anything else there on this side that needs to be written down?
No, -4.
-4, right? Bring that down. Very good, that's taken care of on that side. All right? Anything I do, because I combine like terms over here. Can I do it over here? What would this 21 need to have to be able to combine like terms? A y. It doesn't, right? And this isn't just a 6. All right, it's a 6y. I can't do anything there. Let's bring it down. 21 plus 6y. Okay. Madison, what can I do now? What do you want to do?
You have to bring the 8y over to the other side.
We could do that. We could by doing what?
Dividing. Subtracting.
I could say, because what kind of an 8y is it? Positive or negative? All right. So to move it, I have to do what?
Subtract.
Opposite operation. We can do it this way. All right. We can do it the way that Madison said. If it were me, there's other options here. Let's put it that way. What's another option, Sophia?
You can subtract 6y and then subtract.
I could subtract 6y and subtract 6y from 8y, right? That would give me a positive number. But what Madison said is not wrong. That's another option. There's another option. What could it be? So we've said so far we can minus 8y, minus 8y. We can minus 6y, minus 6y. What's another option, Mallory?
You could do plus 4 to plus 4.
Plus 4 here, what else?
Plus 4 to 21.
Plus 4 to 21. That's another option. There's one more option. X
Minus 21 on both sides.
from what? So minus 21 here? Or from,
Minus 21, -4.
minus 1 from the 4. But Madison was the first person I asked, so she wants to minus 8y. We can do that, and we can minus 8y. That's perfectly fine. Whatever you do with this step, as long as you balance it, you're fine. What's going to happen at 8y minus 8y? What happens, Madison? That's why we did it, right? We want to move it. All right, here's my equal sign. On this side, Madison, what do I have?
You have negative 2.
That's the only thing I didn't touch over here on this side.
Negative 4.
-4, I didn't touch anything, right? -4 equals 21, didn't do anything with it. And you said what? What was this going to be?
Negative 2.
-2y, good. Because ignore the signs, 8's bigger than 6. We know my answer is going to be negative. Take the sign of the bigger number. 8 minus 6 is 2. Okay, now, I think we can get to the part where some people struggle. You don't, see how we just moved something over here? So we don't want to move something else over here. The thing that's still there on the side you just moved something to, you're going to move to the other side. So you're flip-flopping. Move this here, move the other thing, put it on the other side. Like you're rearranging your room, right? Okay, I'm going to put this in this spot. Okay, that means this is going to go over. All right? Like if you're like my mother, she wants to make sure the whole room's like balanced. All right? So we just moved the -2y to the right-hand side of the equal sign. So what's over there now that has to move to the other side? We just moved this over here. Whatever was over there has to go to the other side. So what's on the side where I moved the 8y, I moved the -8y, I moved the -8y, I got -2y. What else was over there? Good, Ginny. What do you want to do with it? Subtract it from 4. So minus 21 here, minus 21 here. When I do that, Ginny, what do I get? So now, they're both negative, right? I'll give you a hint. If we were multiplying, it would turn into a positive, but we're not multiplying. So what's my sign going to be? Negative. What do I do with the two numbers? I think Gemini might have told us this rule earlier. When we have the same sign, we want to do something to the sign and do something with the numbers. Anybody remember that rule? No? Okay, so we're keeping the sign and then doing what with the numbers? Add them. When I add them, what do I get? 25. Perfect, man. Good job. So that does that. On this side, on the right-hand side where I cancel out the 21, what's left? Negative 2y. Nice job, Joe, bringing the sign down too. Don't forget about that because it's on the left. All right. Mackenzie, Do you think you might know our last step? We got negative 25 equals negative 2y. What's the last thing? You don't need to just tell me the operation. You don't have to tell me the numbers. All I want to know is the operation. This means multiplication. I want to get rid of it. What number am I going to divide by, Mackenzie? What number is with the variable? Look at the board. What number is with the variable? Say it. Negative 2, right? That's what we always want to divide by, the number that's with the variable. Negative 2, negative 2. Now in this case, that's going to cancel and give me y equals, we're not going to get a nice whole number here. We're going to get a decimal. Let's go up here. And let's do negative 25. Oops. Oops.
I think press the minus.
Oh, sorry, Mr. Hager. I can use my finger, right? I'll let Mr. Hager do it.
Oh.
So 12 and a half. So in this case, guys, we didn't get a nice whole number as an answer. We got 12.5. That's our final answer. So sometimes most of the time, guys, it's going to work out where you're going to get a whole number as your answer, but every once in a while, you might get a decimal. All right, so that one we had parentheses on both sides. Let's look at the next one. Everybody have this? Can I move on? The people still need to copy it down. Good, speak now. Going, 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 gone. All right, this one. Here's what I want you to do right now. Just for this problem, right now, I want you to do is do distributive property and do combined like terms. Right, so you're going to have both of those going on here. So do distributive property and do combined like terms right now on your own. Remember, here's your sign, here's your sign. You guys can do this. I got faith in you. If you feel like you can go on and do more, and solve it, that's fine.
Right. Who can tell me what do you get when you distribute the 3? Just give me that part. Xander?
3x.
Good?
Minus 6.
Perfect. And what about when you distribute a plus 5? Gemini?
Positive 10.
Yeah, and hold on, I'm going to ask someone else to give me the next part. Positive 10. What's 5 times negative x? Noah?
Minus 5x.
Yep, good job. And let's do one more step together. Any like terms on the left-hand side? Mallory? 3x, negative 5x. Anyone tell me what you get when you combine those?
Negative 15x.
Careful, you're just subtracting. 3 minus 5.
7. Negative 7.
Not a negative 3 minus 5.
Listen, I'm not Mr. Joe. I know everything.
Think about if you had $3. If you had $3 and you spent 5, you'd spend a little bit more than you have. What would it be? Yeah? Valerie? Negative 2x.
You're so smart.
What about those? Negative 6 plus 10. Anyone think someone else that hasn't given me an answer in a while? How about Ginny? Did you get negative 6 plus 10? Not negative 5. Think about if you had 10 minus 6. Same thing. What's 10 minus 6? Not 5. Xander?
Negative 6 to you.
No, if you had 10 minus 6.
I think it's
You have 4.
it's positive. I was thinking negative 4.
Yeah. Okay. 10. Xander, so what is it? Xander? Xander? So what is it? Someone just said it. You weren't listening.
Yes, I was. They just talked softly.
Ginny? Positive 4.
That's what I said. That's right.
Okay, so Take about 30 more seconds and finish that up, because most of it's done now. Okay, second to last step.
That's fine.
You can tell me page.
You would subtract one of both sides.
Yep. Subtract 4 from both sides. What does that leave me with on the left? Just the left side. Left side page.
Negative 2x.
Good. And can someone else tell me what's left on the right? Xander? 12. Last step. What operation?
Division, you're gonna divide 12 on both sides.
Careful.
Oh.
What do you want to divide by?
I'm not perfect. Calm down, bro.
It's okay, Xander. So what do you want to divide by?
Huh?
What do you want to divide by?
2.
2, and what's with it?
Negative.
-2. Remember, we don't divide by a letter. Okay, don't divide by a letter, just the number in front.
I never said 11. I said 12.
I thought you said a letter, and you said X.
Oh.
Yeah.
Darren doesn't come over here.
So what's 12 divided by -2? -6. Okay. Any questions? Fred, any questions? All right, you good? You feel good, Fred? Xander, please sit down.
All you have to do is just say.
So I'm afraid you're going to help me with my next problem.
Bump set, spike feet.
Finish the problem.
Okay, so last problem. Xander, I need you to really stop talking now. All right? If I have to ask you again, I'm going to have to ask you to leave because I can't. You're very disruptive. Okay. It says Jim's age is decreased by 9. What is going to get a variable in that sentence, Fred? Jim's age decreased by 9. Nope, 9's a number. 9's the number. What don't you know in that sentence? To what? What are they asking? What is in that sentence that you don't know? Yeah, Jim's age. So let's let Jim's age be a letter. What should we pick? You could pick anything, but just make sure it. Sure, J. Okay, so Jim's age is decreased by 9. Okay, how would you write Jim's age decreased by 9? Sophia? -9.
What is that word?
Okay, we're going to come back to the rest of it in a second. Jim's age decreased by 9. Now, it says that difference, okay, that thing that we just did, is multiplied by 8. So how would I write that down? If that difference is multiplied by 8, what would I do?
Put 8 next to those parentheses.
Yep. That difference is multiplied by 8. The result is. What does is mean? Equals. And it says, what is the result?
48.
The result is 48. So Jim's age decreased by 9, and that was multiplied by 8, is, that's the equal sign, is how much? 48. Okay. When I do distributive, what do I get on the left? All right, 8J, it's a good start. What else? 72, positive or negative? Positive times negative. Negative And what do I have to still bring down, Sophia?
48.
48. Okay, two steps left. Second to last step. Joe?
Add 72 both sides.
Add 72. Let's just do that by hand. 8 and 2 gives me 10. So carry my 1. 4 and 1. 5, and then 7 is 12. So we get 120. But what's still on the left-hand side? 8J. So that means 8 times Jim's age is 120. So how do I get just Jim's age? Divide, and Connor, can you tell me what to divide by?
120.
Remember, you're trying to get J by itself.
So 120 under 8.
So what's next to J? You always want to divide by the number that's next to the letter.
8.
Yeah, you want to divide by 8 and divide by 8. And if we do 120 divided by 8, that's how old? Is that what it comes out to?
Yes.
Yep. 15. So Jim is 15. I'm just going to put years old.
That one was fun.
Okay? So usually when you have to set up a word problem, the equation you have to solve is not as bad as something like that. Okay? Usually word problems, the equation is a little shorter. Okay? Because you have to set it up yourself. So Mr. Roy and I don't want to make it too complicated. But that's kind of like one you'll see on the test or something similar. Okay, so a couple quick reminders, and then we're going to give you guys one to just practice on your own. Yep. So the homework tonight, it's going to be a worksheet. Okay, Mr. Roy just went to go get it. I told you guys this is the last week before progress reports. Thursday's a review day. What do you have to bring with you?
Our Chromebooks.
Chromebook. And test will be on Friday.